Hi guys, hey, Dr. Tom here, DIY Science Guy. And today we're going to mess around with liquid nitrogen. All right, a very interesting, very cool liquid that has some really unique properties. And we're going to start out by putting a balloon in it. And I want you to predict, what do you think will happen when I put a balloon in liquid nitrogen? And so we're going to start this out in just a second. I gotta grab my handy glove here. All right, here we go. And so I'm gonna put it in liquid nitrogen. I'm dipping it in that container full of liquid nitrogen. And I bet quite a few of you predicted the balloon would pop, but actually, if you can see, the balloon's deflating. And it's deflating pretty quickly. I'm trying to dip it in there, push it down in, and that balloon is deflating because nitrogen is minus 196 degrees Celsius or minus 320 degrees Fahrenheit. So it's really, really cold. So I'm getting this balloon colder than it's ever been. And I'm also getting the air inside it colder than it's ever been. So those air particles are slowing way, way down. And the balloon itself is getting really, really cold too. All right, now I'm about to pull it out of the nitrogen, and I want you to notice two things. Number one, I want you to notice how flat the balloon is. And number two, I want you to see if you can see a puddle of air, because the air inside of that has gotten so cold now that it's liquefied. And you should actually be able to see a little puddle of air. It won't last very long, but let's take a look for it. So there's the balloon. Look how flat it is. Okay, and I'm taking it out now, and there's the little puddle of air. Right there, a small little teeny puddle of air. And I dropped the balloon, but there it is again. There's the small puddle of air. You can, I don't know if you can see it on there, but the puddle of air is right there. The balloon is inflating again as that nitrogen and the air inside is warming up. And you can see it inflates again. Sometimes the balloon survives, sometimes it doesn't. It just kind of depends. This time it survived though, so that's good. It was a really tough balloon in that case. All right, now I want you to predict what do you think will happen when I put an apple in there. All right, so apple is a fruit, a once living thing. I'm going to take a big half of this, dump it in there. And you can see it immediately causes some of the nitrogen to boil off. And you can see it boiling off, and you can hear it boiling off. And one of the questions, guys, is, so nitrogen is really cool, it's minus 320 degrees, but what could you use it for? Like, is it useful? Is it helpful? And it turns out that it's super, super useful, and there's a lot of good reasons to get something to be that cold. And so I want you to kind of think about it and see if you can come up with some ideas yourself as that apple cools down. All right, and then we'll talk about some of those ideas too. But one of the things it's used for, it's used by doctors and dermatologists specifically to freeze warts off and to freeze cancerous cells off the surface of your skin. And it actually does a really good job of that, and it causes less scar damage than if you get them burned off, like I used to have to do when I was a kid. And so that's pretty cool overall. And one thing about nitrogen is that nitrogen molecules look like this. They're a double atom molecule, and they're triple bonded, and they don't have any attractive forces because they're totally nonpolar, and so they don't like to stick together. And so to get them to be a liquid, you got to get them really, really cold, and you got to put them under pressure, and you got to lower the temperature, and eventually you can get it to become a liquid, but it's kind of difficult to do, and it doesn't liquefy into minus 320 degrees, which to me is pretty amazing. All right, now, so I'm going to take a little bit of nitrogen and pour it into some warm water. I want you to predict, this is warm water right here, predict what do you think will happen when I pour it into some warm water. All right, there's some nitrogen here in this container. I'm going to pour some in. And you can see how it boils the water, and a lot of the nitrogen has to evaporate, and that nitrogen evaporates really, really quickly, and you get kind of a witch's brew sort of feel or vibe with it too. So that's pretty cool overall. So now the water's cooling down and a lot of the liquid nitrogen is boiling off. Remember, its boiling point is minus 320, so that's going to boil off for quite a while now until it's all evaporated. All right, so the apple is still freezing, and so we're going to take a look and see. One of the other uses for liquid nitrogen is by restaurants. And restaurants use them to freeze things in certain ways. And you can pour it into your drink sort of like this, and then you can have your drink look really cool and really interesting. You just got to be careful that when you actually drink it, there's no liquid nitrogen on the surface, or you could be in trouble in a hurry. But it's used for specialty drinks quite often, and it's also used to freeze ice cream. There's a place right by our house called the Frozen Cow, and it uses liquid nitrogen to freeze ice cream mixtures. And it turns out when you freeze it really fast, like that happens in liquid nitrogen, you get a very, very smooth texture. And some people really love that smooth texture, and so they're willing to spend more money for that smooth texture overall. Okay, so I don't have any ice cream today, but I do have some little marshmallows, and so I'm gonna pour some liquid nitrogen onto the mini marshmallows, and then I'm gonna eat the mini marshmallows, and we'll see what happens when I do that. So here's the nitrogen. I'm gonna pour it right onto the marshmallows. And let them freeze. And so I think they're pretty well frozen. And then I'm going to actually eat a few of the marshmallows and see what happens. So make sure there's no nitrogen left in there. Well, that's called dragon's breath, because it kind of looks like dragon's breath. At least I hope it did a little bit. But that's pretty neat. And so it turns out the spit in my mouth kind of protects my mouth a little bit, and I can do that with some marshmallows. And that's why you can eat stuff like ice cream with it, as long as you're careful and you don't eat it too fast. Okay, now, so one last question is, what's the main use of liquid nitrogen? So we have ice cream, all right, and we have doctors that use it, but the main use by a long shot is actually by NASA. And NASA uses it to test things that are going to go out into outer space. Because as it turns out, I don't know if you know it or not, but outer space is super, super cold. Outer space is actually minus 455 degrees Fahrenheit. And so it's super cold. It's just about 2.7 degrees above absolute zero. And so when we send things into outer space, we know that they're going to get really, really cold. And so the problem is that the characteristics of things become different under different temperatures. So we have to have a way where we can test things and see how they behave when they get really, really cold. And when we were developing the space program, we knew that astronauts were going to have a spacesuit, and that they were going to have to take spacewalks out into space to like fix like the space lab that they're on, or the space station now, and things like that. So they're kind of thinking, what would make a good spacesuit when we know that space is super, super cold? And one of those ideas was plastic. And this is, when you see this, I know you say it's a rubber duck, but it's actually a plastic duck. And they thought, hey, plastic would be really good because it's tough and it's flexible, and I think it might make a really good spacesuit or not. So they started to think about, well, could we make a plastic spacesuit? And so first, though, what did they need to do? Yep, they needed to test it and see would it work in cold temperatures and then warmer temperatures as well, because it can get warm in space if you're exposed to the sun. All right, and so they decided to use liquid nitrogen because nitrogen was minus 320 degrees, pretty easy to produce. So kind of within a few years, all of a sudden liquid nitrogen became the most important test substance for NASA. So we're gonna pretend that we're gonna make our spacesuit out of this plastic. And we're gonna test it and see if it works when it gets really, really cold. So I'm gonna go ahead and take this and put it in some liquid nitrogen. And you can hear it there. I'm gonna move a couple things out of the way. And remind me, we still gotta look at our apple. And this is my first YouTube live stream. And I know I screwed up by not putting the camera high enough. So if my head was cut off for parts of this, I apologize. Okay, so the rubber duck is in there. And I'm just pushing it in the rest of the way. And wow, it turned out that it broke into pieces right in the liquid nitrogen. And so I'm going to scoop it out so you can see it. And you can hear it. So there you can see it broke apart in the liquid nitrogen, and now it's breaking into real small pieces. And so it turns out that most plastics, when they get really, really cold, all right, they lose a lot of their same properties that they would have at normal temperatures. And so this particular plastic anyway would obviously not make a good spacesuit material for astronauts in outer space. Okay, now the last thing, guys, I want to take a look at real quick is the apple. If you remember, we have the apple in here. We're going to take it out and take a look at it. And they say if I pulled this apple out of here in 200 years, the apple would look the same because it's so cold in there that it can't decompose and it can't rot. And so basically we're stopping it in time. And so let's take a look. We haven't had it in there too long. But you can see there's the apple. And you can see it smoking, and listen to it when I hit it. You can tell it sounds a lot different. And then I'm going to hit it a little harder and look, it cracks in half. And then if I hit it some more, it cracks into even smaller pieces. And so it turns out the apple is real brittle when it gets really, really cold. And so that's pretty interesting overall. And so one of the things we're trying to do is freeze different kinds of tissue so that we can use it later on, like blood vessels and hopefully sometimes organs or something like that. But one of the big things we have to consider and think about is what happens to things when they get really, really cold, like that apple, because their properties and their characteristics change quite a bit. So anyway, I hope you guys were pretty impressed by the liquid nitrogen. It's a pretty amazing substance, has lots and lots of different uses, and there's a lot of good reasons to get something minus 320. So take care and try to check out, if you get a chance, DIY Science Guy on YouTube, and I'd appreciate a like and a follow. Hey, take care. Bye.